This is the lecture for multiple regression with categorical variables. So hopefully you've already found the information you need for the lecture, but I'll just show you where it's found. So we go to the modules, you come down to multiple regression. You'll see the video file there after I recorded it and put it here. This is the R code that you're going to need for class today. It's opening up in R for me automatically. And then in addition to that, you're going to want, well, I don't know if you want, this is the PowerPoint lecture that we'll use. So I'll download that to use that. So after today's lecture, you should feel confident in your ability to do multiple regression with categorical variables. As long as your dependent variable is a number, you should be all set and ready to go. I use this stuff regularly in research. It's like 80% of what you see in published research. So hopefully this fills you with confidence in your ability to do statistical analyses. If you're interested in doing more of this stuff, you should check out the data science certificate that you can get, or a minor in data science. Now that you're familiar with R, you're ready that you could take pretty much any of the math classes at BYU Idaho. They use R and they go more into depth into the stuff. Like in this class, we just brush the surface. We just kind of cover it like almost as lightly as you can. But in these other classes, they go more in depth and you'll become much better at it. We actually have a really good kind of data analytics program here. If you combine data analytics with political science, there's lots of stuff you can do with just an undergraduate degree. So if you have any interest in this, I would encourage you to kind of take those classes. But of course, feel free to email me. We can sit down and talk. We can talk about options that you have and things you might be able to do. Okay, so we're going to cover a lot today. We're going to figure out how you tell which control variables are the appropriate ones to use, how you assess model fit. We'll talk about categorical independent variables, since that's so much of what we do, and how to interpret those, because it's pretty different. We'll also talk about how to interpret or how to present the results. When you learn how to present the results, I hope that you'll also learn how to read results that other people have written in published research. So the R squared gives you some kind of sense about whether the independent variables that you're using do an adequate job of predicting your dependent variable. Right? You can say, okay, these independent variables predict about 22% of the variation in my dependent variable. And so that gives you some sense of how good your model is. But it is also true that the R square can be a little misleading as you get to like higher order statistics. So you shouldn't exclusively rely on that, but for your purposes, it's good enough. Just look at that and say, okay, my model explains like 25%. That might seem small to you. You maybe want to explain 80%, but I'll just caution you, in the social sciences, things are dynamic and it's hard to explain everything. It's hard to explain even half of why somebody is the way they are, or why somebody votes the way they vote, or why they support what they support. So sometimes we're content with explaining a little bit, because explaining a little bit is more than explaining nothing. So the statistical model that you use is based on the theories in your literature review. So as you guys were writing your literature reviews about emotions and voter turnout, there were all these things that predicted voter turnout, right? Like people who are wealthy, who are white, who are older, men, they all tend to be more likely to vote. So if you're going to do some kind of a model where you add emotion into that, you have to include all those other control variables from the voter turnout literature into your model. Then you add emotion in and then see if it's statistically significant. So like here's, last time we talked about how you have a mx plus b, how you have a slope times some value of an independent variable plus the intercept. In this case, for our dependent variable, we're going to predict by the intercept plus a number of slopes for each of the independent variables. Of course, error we assume to be 0, but I just put it on because that's a theoretical model. So let's say we're trying to predict income, why somebody makes the amount of money they make. And there's all this variation. The blue is the variation in income. So maybe people with more Education, maybe that predicts a higher income. Maybe a job with more prestige has a higher income. Maybe the kind of job it is predicts the income, or maybe if it's a blue collar or a white collar, maybe that influences income. So let's model that. So we use the Duncan data. We've used it before in class. I'm just going to assume that I have it in my downloads somewhere. So I'm just going to run that line of code and look for the CSV file called Duncan. Oh, I'll search. Sorry, I was typing it in the wrong place. I have lots of things called Duncan, apparently. Well, I would show you an easier way that I'll get the Duncan data set in. If I go library car, and then load in that library, I can just say D1 equals Duncan, because it's in that library, and then it shows up. So here's my Duncan data set. I've got type. Career doesn't show up, but that's the job name. I've got income, education, and prestige. So there's my data set. So I'm supposed to run a model predicting income as a function of education controlling for prestige. So if you don't remember how to do that, you should actually maybe just try and do it on your own. Maybe you want to pause and then see what I do. So the way that I would do that is I would go mod.1 is a linear model predicting income by education and prestige. And then when I look for the summary of that model, sorry, not of D1, summary of mod, I'll just type in here. Summary of mod.1, then I get this output. So here's my intercept estimate, here's my education estimate, and here's my slope for prestige. So is education a statistically significant predictor of income controlling for prestige? So I look here at education, here's my t-value, it's less than 1.96. My p-value is 0.8, that's not less than 0.05, and there's no stars. So I'd say education is not a significant predictor of income. What's the model R squared? Here's the multiple R squared, and here's the adjusted. You could use either one, but we'll just go with this one, 70%. So of all the variation in income, this model with these two variables predicts 70% of the variation. Of course, this one's not statistically significant. So pretty much, it's a lot like this picture that I drew here. Most of the variation in income is explained by prestige. So how would I interpret that? I just did. Here's the output with like little arrows and such to kind of show you how I got all those values. The p-value is higher than 0.05. Of course, this one is less than 0.05, and it has a star. 1 star means it's significant at the 0.05. 2 stars means significant at 0.01. 3 stars means significant at 0.001. But since in the social sciences we always use 0.05, any stars means that it's significant. So controlling for prestige, a 1 unit increase in education predicts a 0.03 increase in income. That's basically a flat line. It's not statistically different from 0, the slope of that line. So we could predict that, right? If I put in these values from here, so 10.42 plus 0.03 times some value of the independent variable plus 0.62 times some value of that independent variable gives me my prediction. So if I go to here, someone has an education of 52 and a prestige of 81. I just plug it in here, those independent variable values. I have it here in my R code, the code to make that prediction. So this would be education 52, prestige 81. And so then we would predict that they would have an income of 62.2. But like I showed you last time, you can also just paste it in the Google like this, and then it loads up a calculator for you, and you can just change your values here to whatever you want them to be. Let's say 100 education and 20 prestige. It's going to have a really low predicted income because education doesn't matter as much as prestige in terms of as a predictor. So if I were to try and make that prediction, it was 62, right? So we could do it again. So someone has an education of 100, prestige of 16. You can pause and try that yourself, or just change that right there to 16. And I'm going to get, what was that? 23. Someone has an education of 84 and a prestige of 81 in their career. So I change this to 84. I change this to 81. I make my prediction. So then I'm going to go 63. And you get it, right? That's how you do it with multiple regression. When it's numbers, you just plug in the numbers and then you see your prediction. So categorical variables are different. With the categorical variable, you can't tell the absolute effect of a variable. You can only tell the effect of one category of the variable compared to another category of the variable. So for instance, I can't tell you, does gender matter? I can only tell you if men are different than women. I can't tell you if race matters. I can only tell you if African Americans are different than white people. So that's how categorical variables work. I can't tell you if party ID matters. I can only tell you if independents are different than Democrats or different than Republicans. So there's a little bit of trickiness involved in that when you're making those predictions. So that's why we're spending a whole lecture focused just on this idea. So let's say in this income thing that we were using before, we want to know, does a white collar salary worker make the same as a blue collar salary worker? Or does someone in a professional job, do they make the same as someone in blue collar? And the alternative is that they're not equal to each other. So what I'm trying to help you understand here is this variable type. I'm going to go look at the data set again so you can see. This variable type, I've got professional, I've got white collar, I've got blue collar. Or a simpler way to see it is we could do a table of it, right? And look at the variable. And I can see that I've got 3 options in this categorical variable. So because there are 3 options in this categorical variable, if I include it into my statistical model as an independent variable, like I'm going to do right here in mod 2, I'm going to go income predicted by education plus prestige plus type. You see how there's only 3 independent variables. But because there are 3 categories in type, I'm going to actually get estimates for 2 additional slopes. So I only put in 3 variables, but I'm going to get 4 slopes. I'm going to get white collar compared to blue collar, and then professional compared to blue collar. And it'll show me those slopes, and it'll do the hypothesis test. So I'll show you how to do that. So we just run this mod.2, and then we do a summary of it, and then here's our output. So I get education, I get its slope, I get prestige, its slope, professional, its slope, white collar, its slope. And I get a hypothesis test for each one of those. So when there's a categorical variable, R chooses one of the categories to be the baseline. It means that that's the category that everything's being compared to. You can tell which one's the baseline by the one that doesn't show up here. But also in R, you will typically choose the one that's alphabetically first to be the baseline category. So if you were to like put in state as an independent variable, you're going to get 49 different estimates here. And probably, what is it, Alabama? This is before Alaska. So probably Alabama will be your baseline variable. So Alabama wouldn't show up, but every other state would show up, and it would compare how every other state compares to Alabama. So you have to make sure when you're using a categorical independent variable that you're using a baseline that is something you're interested in. Okay, so what's the baseline for type? Well, I know that it's blue collar because I looked here at this table and I saw blue collar was the first category. So, sorry, I got to go back to this slide. How do we interpret the coefficients? Well, it's each of these compared to blue collar. So if I'm looking at it here, I'll show you how you put it in the equation. So let's say that someone has education of 22, prestige of 24, and that it's a white collar job. Let's say there's some job that's like that, right? So here's the way I would make that prediction. Again, I get all my values from here. Here's all my estimates that I'm putting in this equation, right? Okay. So here's my intercept, plus negative 0.13 times 22, that's education, right? Plus 0.88 times 24, that's prestige, plus, now it's not a professional. This is the estimated slope for professional. But since the job is not professional, I put a 0 in here, so that cancels out. Plus, this is the estimated slope for white collar, so I multiply that by 1 so that that stays there. And so what I end up with is I can estimate the effect of white collar by canceling out prestige. If I wanted to know blue collar, I would put a 0 here and I would put a 0 here. And it would be neither of those. It would just be this part without those two, because the zeros would cancel it out. So the way you interpret it is relative to the baseline, right? On average, white collar jobs earn 19.39 more than blue collar, and professional earn negative 7.26 less than blue collar. Okay, so let's play around with this. I'll kind of copy this. Actually, I think I have this code in here. Yeah. So I'll copy this and I'll paste it in the Google so we can have fun with it up in the Google. Okay. So this says to predict. This says predict a job, the income for someone. Education's 98, prestige is 7, and it's professional. So in Google, I change this to 98. 98, prestige is 7. The job's professional, so this becomes a 1, and this becomes a 0. And so in that situation, we predict negative income, which is hopefully exactly what we'll find there. Yeah, okay. All right, what if their education's 7 and the prestige is 98? So this one, I think we're just switching them around, right? It's still professional. So what is it? Education is 7. Prestige is 98. And then we predict a much higher income for them, right? And then we predict 85. So if you remember when I was teaching you how to do linear regression, I was saying you just draw a line, right? You can't draw a line with this. Here's a slope, here's a slope, here's a slope, here's a slope. It's a multi-dimensional figure. I can do a 3-dimensional figure when I've got 2 slopes. But once you go more than 2 slopes, it's just hard to know how you even draw that as a figure. So instead, what we do is we put it in a table, right? This is a regression line with just 2 predictors. It's like this plane, right, that you're trying to predict on. Once you go more than that, I can't even conceptualize visually what it looks like. So what we do instead is we put it in a table. So there's this package called Stargazer. So first you have to install it. So I'll show you. So there's a number of ways you can install it. I can just go to packages and I can go install and start typing in Stargazer, and then it'll install it. Or I can run this code right there that says install.packages Stargazer. Then you have to load it in. So you can either just check the box right here on Stargazer. I have lots of packages. You can just check that box. Or you can type in here library Stargazer. Or you can do require Stargazer. All of those do the same thing. Okay. Then you use this code, Stargazer, and you put the model side by side, mod.1, comma mod.2, and then say type equals text. And then you're going to see something that hopefully looks familiar to you. So this looks like the kinds of tables you see in social science research, right? Only it's a little nicer. So here I see education, and then you see how we set it up. You have the estimated slope, and then below it in parentheses, you have the standard error. So this divided by this gives you your T statistic. And then also we have this little note down here that tells us that these ones are significant. We even put stars by them, and we say that they're significant at the P is less than 0.01 level. So this is the way that people are used to seeing statistics, right? The results of regression models. I've got my estimate, I've got my standard error. Estimate, standard error. So this divided by this equals, I'm not that good at math, so I'll look at R, my R code up here. 0.883, sorry, I gotta go up here. 0.883, 6.687. So this divided by this is 6.6 whatever. That's bigger than 1.96, plus it has a star, so it's statistically significant. Professional is not significantly different from blue collar. White collar is significantly different from blue collar, and it's kind of large, right? Here's my R squared. Here's my adjusted R squared. If I were publishing this in a paper, I would just pick one of those to report. Here's my sample size. Okay, so now you know how to create the kinds of tables you would see in like research papers. You'd have to clean it up a little like that, make that word like something nicer than type prof. That's weird. But you could clean it up. And hopefully now you can interpret it. You should now be able to look at any statistical table from any like social science research that you look at and say, okay, here's my dependent variable, income, that I'm trying to predict. Here are my independent variables that are predicting that. These are slopes. This is my intercept. This is the standard error that I use for my statistical hypothesis test. And then if there's stars, it's statistically significant. If there's no stars, it's not statistically significant. So education is not related to income. Prestige is related to income. You should be able to do that. But we'll let you practice right now, because practice makes perfect. So now I want you to use that attribution recode data set. We're going to call it D2. So I'll read that in. On mine, it's line 16. And then I'm just going to look for attribution. Oh, where did it go? All right, I'm going to cancel that because I lost it somehow. What did I do? Oh, there it is. Okay. I don't have that data set there. So I'm going to go to iLearn. I'm going to find the data set. I think it's in this thing called, oh, when did we use it? I think we used it in t-test, I think, right? Let's see if it's in data sets. Oh, there it is, data sets, data for class. So I'll download that. Okay. Now I'll read it in with line 16. Where's that little thing? I gotta find that window. There it is. Now if I start typing in attribution, there it is. Okay, 1,800 observations of 19 variables. That sounds about right. Okay. Now time for you guys to play. I want to know if older people are more religious than younger people. So we're going to control for education, partisanship, and ideology. And you say, well, I don't know what the names are for those variables. Well, here's how you do it. If you just type in names of D2, it tells you all the names of the variables in the data set. Or if you go summary of the data set, then it also tells you all the names. But that's sometimes harder to use. So I use this names thing, and then I say, okay, I want to know. So my dependent variable is going to be religious something. So there it is. That's my dependent variable. And I can control for education, partisanship, and ideology. So in here I see education, ideology, and partisanship. Let's use that one. So go ahead and pause it. Try try and do this on your own, because you'll be a lot happier if you don't watch me do it. If you watch me do it, you're not going to learn as much. You'll learn way more like struggling through this, trying to do it on your own and failing lots of times, and then coming and getting help. Okay, now you're going to see me do it super fast. I don't know, maybe you're faster than me at this. I'm going to call it mod.1. Wait, yeah. Mod.1 equals LM of religiosity. I spelled it wrong because remember it's reverse coded. Predicted by education plus age. I'll do age first. Predicted by age plus education plus ideology and partisanship. Data equals D2. I'm going to do it, and then I'm going to go stargazer. Mod dot, what did I call this thing? 1 type equals text. Okay, so here's my output on this variable. Here's religiosity, here's age categories, here's education categories, here's ideology categories, here is party ID categories. Here's my R squared. So my model explains about 19%, 18% of all the variation in religiosity. You notice I didn't even put in religion. I didn't put in anything related to religion. Okay. Here's the question then. Compared to young people, older people are more religious. Is that true? Is that false? Or is that not enough information? So we'll look at the table. We're like going to compare young people to old people and see who's more religious, right? Okay, so looking at that, you might have a decision. You might have figured out what you think it is. I'm going to tell you the answer is not enough information, because I have here ages 18 to 25, 26 to 35, 36 to 45, 46 to 55. I have the oldest you could possibly be. I have the youngest you could possibly be, because if you're under 18, you're not allowed to take national surveys. And I have everything in between. So what I don't know is who these are being compared to. Who are they being compared to? If I want to know the answer to that, I need to make a table of the variable. It's D2. And then I see they're all being compared to missing values. 114 people didn't answer the age question. And so all this is telling me is how these age groups compare to people who didn't even answer the question. So we need to change that. What we're going to do is, since my hypothesis is that young people are less religious than old people, we'll make young people the baseline category, and then all these groups will get compared to them, and then we'll be able to tell. So here's how you do it. You just say this variable, D2 $age, equals re-level of D2 $age, and say that the reference category is 18 to 25. That, if you just copied that, it wouldn't work. That's weird. R is not going to like this little, that symbol isn't going to work in R. But it's in the R code right here, line 22. So if I run that, now I run levels, you see missing is now going to be compared to this. And what we're going to do is we're going to run that exact same model again, but this time we'll call it mod.4. I guess I got to call that other one mod.3 again. So I'm going to just run that model again. I'm going to call it mod.3. Oh no, it's not going to work. Okay, I'm going to go mod.4 because I already re-leveled. And now in Stargazer, I'm going to go mod.1 and mod.4. And now I have something that I can look at. I can now answer this question because look what it is. See, my second model, 18 to 25, is the baseline category because it's the missing category. Here's the first model that I ran. You see that everyone was being compared to missing values. Okay, so now missing values are lower, but not significant. You see how there's no stars here? So what this means is statistically, every age group is the same amount religious as 18 to 25-year-olds. Remember, the religiosity variable is reverse coded, so higher values mean you're actually less religious, right? And also remember that it measures practice of religion. So how often people pray, go to church, read their scriptures, how much they believe in God. So you can tell people who say to you that younger people are less religious than older people, you can say, actually, that's not true. In fact, statistically, every age group is the same in terms of religiosity. But if we really wanted to say which group is the least religious, it would be the boomers. 56 to 65 are actually the least religious of all of the age groups in America. These data are from 2014. So just for fun, this isn't going to help you necessarily with the assignment, but I'm just going to re-level this and see if they're statistically different from anyone. I don't think they are, but I'll just do it for fun. So I'll put in here the boomers, and then I'll call it mod.4, sure, why not? Run it again, then do that stargazer. So now that I have these boomers in, there's still no statistically significant differences. But you see that the signs on all of these is now negative, right? So everybody's more religious than boomers. But if, right, the most religious compared to boomers would be missing values and 18 to 25-year-olds. Okay? All right, so that's our question on age. Let's look about Democrats. Are Republicans more religious than Democrats? So here I might regret that I put in so many party ID categories, but it's okay. So here's independent, lean Democrat, lean Republican, Republican, strong Democrat, strong Republican. So our baseline category is just Democrats. So I'm going to actually change this so that our baseline category is independents, so that we can just kind of compare. I'll call it mod.4 again. This one has to be party ID though, right? And this one has to be party ID. Okay, then I'll run mod4 again. And then I'll put it in here again. Okay. So here's the one we're looking at, right? Independence is my baseline category. So Democrats and independents are the same amount religious as each other. Lean Democrats are actually a little bit less religious than independents. Republicans, statistically the same. Strong Democrats are significantly more religious than independents because it's negative, it's significant. Negative means more religious on this scale. Higher values is less religious. And strong Republicans are more religious. So actually what you can see by looking at this model is that there's no difference between Democrats and Republicans in terms of religiosity. They're statistically the same as independents. And strong Democrats are actually more religious, as are strong Republicans more religious than independents. We could change the baseline on this again if we wanted to. If you say, well, let's actually compare strong Democrats, right? There's this stereotype that strong Democrats are like the least religious people in America. So let's run the model and see if everybody's more religious than strong Democrats. So here's my baseline. Oh, I didn't run the model again. Run the model again, then do the stargazer. All right, so here's my baseline is strong Democrats. So who is less religious than strong Democrats in America? Here we go. Independents are less religious. Democrats are less religious. Lean Democrats are less religious. Lean Republican, and then Republicans are all basically the same. So a strong Democrat is just as religious as Republicans. And then these Democratic leaners and independents and Democrats are all less religious than strong Democrats. So in response to this question, Republicans are more religious. It's true. Well, actually, now I got to change it again to actually test that exact question, right? Get rid of the strong. So let's go Democrat. Run the model again. Okay. Republicans compared to Democrats, no difference. They're exactly the same. Okay. Compared to Democrats, Republicans are more religious. That would be false. They are statistically the same. Compared to Democrats, independents are more religious. Okay, independents, statistically the same as Democrats. Independents are not more religious than Democrats. I'll show you what this, okay, well, whatever. Now we'll go to political ideology. I'll just show you. What that other thing was doing is, it doesn't matter. All right, compared to conservatives, very conservative people are more religious. So let's look at conservatives on here. Political ideology. Okay, I've got liberal, moderate, somewhat, very, very. Okay, so baseline is already conservative. Okay. Compared to conservatives, very conservative people are more religious. I've got stars, and it's negative. So very conservative people are more religious than conservatives. That's true. What about somewhat conservative? Are they more religious than conservative? Go to somewhat, no stars. So statistically, they're the same as conservatives. So that would be false. Liberals are more religious than conservatives. Let's see. Here's liberal. It's got stars, but it's positive, so that means less religious. And in fact, you can just look at the slopes on this. So moderates, significantly different than conservative. So somewhat conservative is the same. Moderates are significantly higher, which means less religious, and it's 0.064. Then somewhat liberal, about doubles the size of the slope, and it's significant. Then liberal, about doubles the size of that slope, and it's significant. And then very liberal, oh, I see. So liberal's there, sorry. So very liberal is double the size of the slope from somewhat liberal. So you can actually go through it, right? You can say, looking at the numbers, moderate, somewhat, liberal, very liberal. So it is fair to say that the more liberal you are, the less religious you are, and the more conservative you are, the more religious you are. So that pattern kind of holds. So yeah, you could just kind of go through. And so in terms of ideology, things are probably what you would expect. But in terms of party ID, they're not what you would expect. Okay, so that is multiple regression. So you guys should be set. Let's take a look at the homework. I'm going to just close this. I'll close that. Okay, so if we look at the homework for multiple regression with categorical, it's got some things it wants you to do. This is kind of one of your tougher homework assignments. So on this one, sorry, wrong one. On this homework, we're going to run a regression model predicting salary by number of publications. Then you're going to add in sex as a control variable. Then you're going to add in department as a control variable. And then you're going to re-level, just like I showed you how to do in class. If we look at the quiz questions, yeah. So it's just a matter of interpreting the stuff that we talked about in class today. So again, I'm available to visit in my office if you want. I'm available to chat on Zoom if you want. But I wish you luck. This should be lots of fun for you. You should feel empowered. There's only one more video I'm going to record. It's going to be the final exam review. So make sure you're ready for that. Then the final exam is a take-home exam. Okay, good job, everybody.